welcome back to our January 2013 Regents exam. Alright, let's get started. What is the equation of the graph shown below? Well, just to start this off, this is an exponential equation by looking at my choices, and exponential equations are always y equals something to the x power. So we can get rid of choices 3 and 4 automatically. Now I'm left with looking at 2 to the x and 2 to the negative x. Well, 2 to the x would be increasing, that would be positive, so that would be going this way. And 2 to the negative x is kind of like having a fraction in there. If you type it into the calculator, you will see that choice 2 is what matches it the best. Number 2, which ordered pair is a solution of the systems of equations shown below? You can't just type this into the calculator because this bottom equation is a circle and the top equation is a line. So we're trying to figure out where the circle and the line intersect. The best way to do this problem is to just start substituting in and see which one works for both equations. If I do substitute in 2 for x and 3 for y, I would get 2 plus 3 is 5, so that works. If I put in 2 for x, 5 squared is 25, and then 5 minus 3 is 0, 0 squared is 0, so 25 is not equal to 53. We can get rid of this one. 5, 0, 5 plus 0 is equal to 5, that works. 5 plus 3 is 8 is 64. 64 minus, 64. And then 0 minus 3 is negative 3. Negative 3 squared is 9. 64 plus 9 is not 53, so we can get rid of choice 2. So let's try choice 3. A negative 5 plus 10 will give me a positive 5. A negative 5 plus 3 will give me a negative 2. Negative 2 squared is 4. 10 minus 3 is 7. 7 squared is 49. 49 plus 4 is 53. So it's choice 3. Okay, number 3. The relationship between T and a student's test scores and D in the student's success in college is modeled by the equation D equals 0.48T plus 75.2. Based on this linear regression model, the correlation coefficient would be between what? Well, we know it's not equal to 0 because the correlation coefficient, to have a line of best fit, in order to have a line, it can't be 0. This is not we don't know if it's a perfect correlation, but because I have a positive slope, that means that the higher the score, the more success they have. So I would not have a negative relationship. So it can't be equal to negative 1, and it wouldn't be between 0 and negative 1, which leaves me between 0 and positive 1. What is the common ratio of the geometric sequence shown below? Well, just take 2 terms next to each other and divide. 4 over negative 2 is negative 2. I could do negative 8 over 4. I'd still get negative 2. No matter how you look at it, I still get negative 2. Given the relation 8, 2, 3, 6, 7, 5, k, 4, what value k will result in the relation not being a function? Well, to not be a function, that means my x values have to repeat. So I'm looking for either an 8, a 3, or a 7. And the only one that fits that is the 3. Which expression is equivalent to 9x squared, y to the 6th, and negative 1/2? Well, negative 1/2 means I need to turn it into a fraction right away. It's 1 over 9 x to the 2nd, y to the 6th, and then I'm going to raise that to the 1/2 power. 1/2 power square root. Square root of 1 is 1. Square root of 9 is 3. The square root of x squared is x. square root of, why I put 6 in instead of y, I don't know. Y to the 6 is y to the third. So it is indeed choice 1. The fact that this was a negative exponent meant I can get rid of choice 2 automatically. For number 7, in a certain high school, a survey revealed the mean amount of bottled water consumed by students each day was 153 bottles. With a standard deviation of 22 bottles, the mean is 153. Assuming the survey represented a normal distribution, what is the range of numbers of the number of bottled waters that approximately 68.2% of the students drink? So that goes one standard deviation above, one standard deviation below. If you don't remember your percentages, look them up on the chart. So if I add 22 here, I'll have 175. If I subtract 22, I will have 131. So it's between 131 and 175, which is choice 2. These would be half standard deviations right here. What is the fourth term in the binomial expansion x minus 2 to the 8? Well, I will have 8c0, 8c1, 8c2, 8c3, x to the 8, x to the 7, x to the 6, x to the 5th. Okay? And then I have negative 2. Negative 2 to the 0, negative 2 to the first, negative 2 to the second, and then negative 2 to the third. Now my exponents must add up to 8. So negative 2 to the third will give me a negative value, which is negative 8. So if this is negative, that means I have to write this choice. The other way I can do that is remember this is positive, this is negative. Positive, negative. So I really didn't even have to figure out what it was, just know that that was negative. And they're all 448. Number 9, which value of k satisfies the equation? Well, I have to get my bases the same. The only way they can be the same is if they are both 2. 2 to the third, 2 to 3, k plus 4 equals 2 to the second, and then 2k minus 1. Now remember, just distribute to your exponents, so it becomes 9k plus 12 equals 4k minus 14. So subtract 4k, 5k, and subtract 12 equals negative 26. Alright? No. Okay. And then divide by 5. This is not working out here. I made a mistake somewhere. Okay, look at what I did. 2 to the third. Oh, that's a 1. I did minus 2. My bad there. That's a minus 2. I'm subtract out at minus 14. It's not the other solution. So that is choice 4. For number 10, there are 8 people in the tennis club. Which expression can be used to find the number of different ways they can place first, second, and third in a tournament? Well, if order matters, combinations are out. permutations are it. I have 3 places, so I have 8 of them, and I'm picking 3. So 8 for 3. Number 11, if the sine of A is equal to 1/3, the value of cosine of 2A. Well, we have 1 minus 2 cosine squared A. I believe if we look up our formula in the back of the book, yep, and that's the right formula. So I do 1 minus 2 times 1/3 squared. So 1 minus 2 times 1/9. So 1 minus 2/9 would be 7. For number 12, in the interval 0 is less than or equal to x less than 360, tangent is undefined when x equals, well, this is just something we need to know, 90 and 270. Tangent is undefined when this tangent is sine x over cosine x. So when cosine x equals 0, x is 90 and 270. And you can do that on your unit circle and look for the x values to be 0. Number 13, the domain of 9 minus x squared. I'm sorry, what is the domain in the range of f of x equals the square root of 9 minus x squared? Well, what I would do is just start testing values. Put it in the graphing calculator if it helps you. And you will see that you can have any values of x that are between -3 and 3. And if I limit those things, then I have to limit my range to be between 0 and 3. So it's choice 1. What they've done is they've kind of restricted our domain. And when we restrict our domain, we can restrict our range. When x squared plus 3x minus 4 is subtracted from this, the difference is, well, it's what I'm from first. So it's x cubed plus 3x squared minus 2x. And then it'll be minus x squared minus 3x plus 4. So now I'm going to add them because I've changed all my signs. X cubed plus 2x squared minus 5x plus 4. I mean, knowing that this became a positive 4, I could have automatically gotten rid of those two. And then I just had to watch my sign. Alright. Next, in the diagram below, the length of which segment is equal to the exact value of sine theta. But believe it or not, we actually talked about this. Remember, this distance here is x, this distance here is y. Sine theta is equal to opposite over hypotenuse. My hypotenuse is 1, so sine theta is equal to segment TS over my hypotenuse, which is TO, and in this case, TO is 1, so it's TS over 1, which is choice 2. Or just the fact that that's the y distance, and that's what we talked about in class. Alright, the area of the triangle ABC is 42. If AB is 8 and angle B is 61, find the length of BC. Draw a picture. Angle B is 61. And we know that AB is 8. We are trying to find the length of BC. Well, we have 1/2 x times 8 times the sine of 61, and it's equal to 42. That's what they told us the area was. So what we need to do is basically half of 8 is 4. So 42 equals 4x times the sine of 61. Divide both sides by 4, sine 61. And when you do that, this is what you get in your calculator. When factored completely, well, I have 4 terms. I'm going to look to do factor by grouping. If I take out an x squared, I'm left with 3x minus 5. Here, I'm going to pull out a negative, and the largest value that goes in there is 16 in both of them. So that will leave me with 3x minus 5 again. So I have 3x minus 5, and then x squared minus 16. Well, I see that as a choice, but remember when we did the other test, completely means you have to factor more than once. So that gets rid of this one, and oh, that's all I get rid of at this point. So it's equivalent to that answer. So which one of these is equivalent? Well, it can't be this one because it's plus 16. So let's get rid of that one. So now I'm left with this, which is still 3x minus 5, and I only see one of those. And this is a difference of 2 perfect squares, so x minus 4, x plus 4. That is choice 3. Number 18. Moving right along. The value of the sine of 180 plus x is equivalent to, well, we have to go to the back of our book and get our formula, which is sine A cosine B plus sine B cosine A. Let me double check on that one just to make sure we have it right. Sine A cosine B plus, this should be, well, cosine A sine B. I changed the order, but I'm going to multiply everything in there. So it should be cosine A sine B. My mistake there. I'd still get the same answer. But this is A, this is B. So it's the sine of 180 cosine x plus the cosine of 180 times the sine of x. Well, the sine of 180, sine looks like this. This is 180, halfway is 0. So 0 times cosine x plus, well, cosine term starts like this. Cosine of 180 is negative 1. So it's negative 1 times sine x. So this is going to cancel out. Negative sine x is 18. Oh, yeah, the sum in simplest radical form. Well, in order to add those, we have to have like radicals. And currently, we do not have like radicals. Let's see here. An A can come out. So this would be A, and then cube root 6AB squared. That's what we're looking at for the inside. So 162 divided by 6. I have a hunch it goes in. That's 2 times 1242. And it looks like, right, 27 times. So this is 27 times 6. The cube root of 27 is 3. A to the 4th becomes A. I divide by 3, cube root of 6AB. squared. Now my radicals are alike. I have an a plus 3a, which gives me 4a. The only choice for the 4a is this one right here. And looking at this, I'm never just going to add the two roots together. I can get rid of that. And what else could I probably get rid of? My radical shouldn't get any bigger than one of the ones I already have. So I can get rid of that one. It should only get smaller. Ooh, 20. Which equation is represented by the graph below? This one actually doesn't look too bad. We're starting up, so it has to be a cosine graph. So let's get rid of choices 2 and 4. My amplitude is 2. Okay, so we have 2 for both of them. On top. It takes me 2 pi over 3 to complete one cycle. So how many cycles would I have between 0 and 2 pi? I need to know how to get to 2 pi. Well, let's see here. 2 pi, so 2 times 180 is 360. 360 divided by 3 is 120. How many times is 120 go into 360? That's 3 times. That means this curve would repeat itself 3 times between 0 and 360. So it's 3x, which is here. And typically you don't use the value that's here in your equation. Alright, for 21. The quantities in P and Q vary inversely. Yay. P is equal to 20 when Q is equal to negative 2, and P is equal to x when Q is equal to negative 2x plus 2, then x equals. Well, remember it's going to be P times Q equals P times Q. So 20 times negative 2 equals x times negative 2x plus 2. So I have negative 40 equals negative 2x squared plus 2x. Now let's get this equal to 0. So I'm going to add 2x squared and subtract 2x. So it'll be 2x squared minus 2x minus 40 equals 0. Factor out the 2, so I'm left with x squared minus x minus 20 equals 0. So then 2x minus 5, x plus 4. So x is 5, and x is negative 4. And that is choice 1. I mean, it was a quadratic. It was possible that only one answer could work out, but probably could have eliminated choices 2 and 4 once I figured out I had a quadratic equation. Number 22, what is the solution set of negative radical 2 secant x equals 2 between 0 and 360? Well, divide both sides by negative radical 2. So I have secant x equals 2 over negative radical 2. Alright, secant is the same thing as cosine, except it's reciprocal, so it's negative root 2 over 2. Cosine is negative in 2 and 3. So we need to look for answers that are in 2 and 3 only. Well, for 22, there's too many answers there, and one of them is in 1 and one of them is in 4. For number 2, 315 is in quadrant 4, so that's not going to help. So, well, if 315 is still in quadrant 4, we're stuck there, so we'll really only have one choice. Cosine x is equal to radical 2 over 2, so that's when cosine x is equal to 45 degrees is my reference angle. So that indeed would be 135 and 225. I didn't even really need to know that by my choices. For 23, the discriminant of the quadratic equation is 24. So my discriminant is 24. 24 is not negative, therefore it's not imaginary. 24 is not equal to 0, therefore it's not equal. 24 is not a perfect square, therefore it's not rational. Irrational. So if I were, the discriminant is b squared minus 4ac, and that's the part that's underneath the radical in the equation. You can't get the square root of 24, so therefore it's irrational. How many different six-letter arrangements can be made using the words tattoo? Well, I have 1, 2, 3, 4, 5, 6 letters. So it's 6 factorial, but the T repeats itself 3 times, and the O repeats itself 2 times. So this is like 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. So 3, 2, 1, gone. 2 in the 4 2 times. So I have 6 times 5, which is 30. 30 times 2 is 60. Or you can type it into your calculator. Remember where the PRB button is. Alright, here we are. 25, expressed in the simplest form. It is equivalent to. Well, the only difference here is the fact that these two are changing their opposites. So I need to multiply the top and bottom by negative 1. So that means I have 3y minus 9 over 2y minus 6. And there is choice 2. It didn't ask me to solve for anything, therefore nothing really should have canceled out. Oh, a lonely log question. If log 2 is equal to a and log 3 is equal to b, express log of 9 over 20. Well, first of all, it gives me 9 minus, so I log of 9 minus the log of 20, which isn't going to help me. 9 is 3 squared, and then 20 is, let's see here, 2 times 10. So this becomes 2 log 3 minus the log of 2 plus the log of 10. So it's 2 log 3 minus log 2 minus log 10. The log of 10 is 1. Log of 2 we said was a. Log of 3 is b, so it's 2b minus a minus 1, which is choice 2. And then for 27, the expression is the equivalent to, well, good thing I got lots of room right here to work. X plus I times x plus I minus x minus I times x minus I. So I need to do a little bit of FOILing here. So I'll have x squared plus xi plus xi minus, or plus I squared. That's the first one. Minus x squared minus xi minus xi minus I squared. So this gives me x squared plus 2xi. I squared is negative 1, so it's minus 1. Minus x squared minus 2x. I squared is negative 1 times the negative, so it's plus 1. So I have x squared plus 2xi minus I minus x squared plus 2xi minus 1. Well, my x squareds cancel each other out. Let's see here. And I want to make sure. Negative RI times I is, oh, my mistake. My goodness. That should be plus I squared. I'm just going to make this minus, we're going to make this plus. So now I'm left with my 1's canceling out. So I have 2xi plus 2xi, which is 4xi, which is choice 4. Alright, that was part 1. Some of these questions were a little bit different than what we've been seeing. This last one was quite extensive. We haven't seen one like that. And some of them are like some of the questions we have been seeing. So take advantage of the easy ones and do your best on the hard ones. I will make a separate video for parts 2, 3, and 4. Happy studying!